is Kara Christensen, and I am going to be doing this presentation on an exoplanet called Kepler 421b. And before we get into the planet itself, I just want to explain what an exoplanet is. That is a planet that is found outside of our Milky Way galaxy. It's found in a different galaxy. This particular planet, Kepler 421b, was discovered in July of 2014, and a few different things attracted me to this planet, and this is why I chose this. It's very similarly compared to a planet in our own Milky Way galaxy, and we know that as Uranus. It also is considered one of the first ice giants that is found outside of our solar system. So I thought that was pretty interesting, that it was a first for astronomers. This particular planet has two stars that it orbits. It has a host star and a binary star that it orbits. And because this is a transiting planet, it's actually also the longest transiting planet, and it takes about 704 Earth days for it to orbit its host star. Another thing that I thought was pretty interesting about this is usually with transiting planets, it takes about 3 transits to require the confirmation of a planet. This particular planet, Kepler 421b, only took 2. The high signal to the radio noise ratio was significant enough, and that happened twice. They were able to get that twice, and that was significant enough for them to classify this as an actual planet. And like I mentioned before, it's very easily compared to our own planet Uranus. It's slightly larger than Uranus, but the mass is unknown. It's so far away. So I want to get into a little bit about this planet and about how it was discovered. So when astronomers first discovered the galaxy that this planet was in, it was found due to a phenomenon called gravitational microlensing. And what that means is when the gravity of a star focuses the light from a more distant star and magnifies it like a lens. So this particular planet has 2 stars. So it was able to magnify that, and very rarely will they be able to see a planet when this happens, but they were able to detect this twice. So in this particular case, 2 separate times that they did a microlensing analysis. The first one happened in 2008, and that revealed the main star, the host star, which I believe is named Kepler 421. This happened, and it is suggested that the planet was there, but again, they had to have confirmation of that. They had to have that happen more often. They did find the star. And then again in 2010, this happened, and they were able to confirm the presence of the planet. Like I mentioned at the beginning, this planet takes 704 days to orbit this host star, so it's well over a year in Earth days. This microlensing analysis was done in Chile, and actually both observations were done in Chile, and it was officially made a planet in July of 2014. I want to talk a little bit about what makes this planet an ice giant. So I thought that was a little bit interesting too, because all of the articles that I pulled up mostly read of headlines saying first ice giant discovered outside of our solar system, or outside of our galaxy, excuse me. So it's no secret that astronomers have discovered hundreds of planets outside of the Milky Way, and for the most part, those are broken up into two categories, or two categories of planets, being the rocky planets, which would be similar to like Mars and Earth, and the gas planets, which are similar to Jupiter, Saturn. But there's also ice planets. And before they demoted Pluto as a planet, I think I remember learning that that's mostly what Pluto is made out of because it's so far away from the sun. And Kepler 421b is so far away from its host star that it gets very little light from its host star. It gets a little bit, but not enough to be affected really by any light or to be hot. So it's very much considered an ice giant because it's so far away. Very much like the planets in our own Milky Way galaxy, Uranus and Neptune are mostly composed of hydrogen and helium and methane, which gives it that blue-green hue to it, makes it very pretty to look at. Much like that, that's what is considered to be the components of this planet as well. They very much consider it to be that blue-green from the methane, but instead of gas, because like I said, it's so far away from its host star, they believe it to actually be made of methane ice. So it's still got that hue, it's still got that beautiful blue-green color, but it is, instead of being formed by dust, that like rocky dust material like Mars or like Earth, it's solid ice. There is a invisible line, so to speak, in many galaxies, and it's called the frost line or the snow line. And basically, anything that is close enough to whatever star that an exoplanet or a planet orbits around that's affected by the heat would be considered a rocky planet or exoplanet on one side of that frost line. And on the other, it's so far away that it would be considered rock ice. So this planet is very much found on the side of the frost line that would be considered rock or ice. And like I said, they very much think that the majority of this planet is comprised of methane ice. I thought these things were really interesting about this planet. Because it's an exoplanet, there's not a ton of information available to us. It's very hard to capture images of it. It takes an extremely long time to orbit its host star, 704 days, Earth days. So a lot of this information is suggested about it. Hopefully in the future we can learn more about it. And although it's very comparable to some of our own planets like Uranus and Neptune, they just really don't have a ton of information on it, including like the mass, the components, what it's made up of. I thought this was a really interesting topic. I hope you guys have enjoyed it. I hope you've learned about something new. And thank you for listening to my presentation. Thank you.